Hey guys, welcome back to a new video. So in this video, I'm showing you guys how to read handwritten digits from 0 to 9 with Python. So let's jump right into it. So we're going to be using my library Handwritten Digit Recognition to do this fairly quickly. And before we actually jump into it, I want to tell you that the libraries I used to make this library is TensorFlow and OpenCV and some NumPy. So you can see all these libraries are very heavyweight. And so in this video, I'm not going to actually uh, show you how to install it and do it on my local disk on my computer. I'm actually going to use Google Colab because it already has most of these libraries installed, and the installation process will run fairly quickly. I know on some applications, if you're using online, maybe like Replit or Trinket, it actually just doesn't run through the installation for like TensorFlow, and I think any libraries over like 200 KBs. So just so we're on the same page for the installation, I'm going to use Google Colab today. All right, so here's the PyPy page. I'll put this in the description if you'd like to look at this. But really what we're going to be looking at is this pip install handwritten digit recognition. This is how we install it. It kind of shows you how to do it right here and some information, but for the most part, we're going to be covering that today. So let's actually just copy this and then go to a new Google Colab notebook. So we just have to type Google Colab and make sure that you have a Google account or a Gmail. So if you don't, you might want to create one, or you could just do it on your local computer. But I'm going to be using Google Colab. All right, so let's just create a new notebook by going to collab.research.google.com/#create=true, and it creates a new notebook for us. All right, so we can actually connect it to their machines. And now let's just retitle this to HWDR as handwritten digit recognition. All right. So the first thing we want to do is we want to install the library. So you can see we already copied it here if you want to do that again. And then now we just have to hit Control V to paste it. And let's just run this cell and see if it works. So you can see fairly quickly it's installed. Most of the things you can see it already has TensorFlow here. So see that's 462 KBs. So that ran fairly quickly, and you can see it successfully installed handwritten digit recognition. All right, so that worked great. Now we can delete this and start writing our code. So the first thing we want to do is we want to import it, import it. So you want to say from a handwritten digit recognition import all, just like this. So that will import it for you if you'd like to run this. That's great. What this is actually going to do is it's going to create your model. So you can see it's running through some epochs. That's just because it's creating a model and it's creating its first. It's creating a model and it's putting its first the first data into it. So here, if we actually go to our files, you can see we just have our regular files, our default files that comes by creating a new notebook. And now when this is done, it actually creates this digits.model, and this will be your model. So it saves everything to this digits.model. So next time you run it, it'll save all the information that it already has, and we'll just add to it. Great. So now what we can do is we can initialize a network by saying net is equal to network, just like this. This is just going to create one network, so we could use that and run our application. You could create multiple of these if you'd like to run and test multiple files, things like that. But for the most part, we only need to use one. And now we can actually do the coolest part, which is actually running the model. So we just have to say net.run, and inside this parenthesis, we want to put the file of the handwritten digit. So here's just the file. All right, so I'm going to pull up an image from my computer of like a 2. So you can see it's right here. Sorry for the background noise, by the way. So if we open this, and you can see this file if you want to see it. You can see it's like a 2. So let's try to actually see if our program could test it out and see and figure out that it's a 2. All right. So let's just put the file name inside here. So this would just be digit2.png. And now let's run this. So it's going through the epochs. You can see we have 3, and let's look at some of these things. So we're not going to talk too much about loss today. I do have some, I have a lot of neural network tutorials, and I'm planning to publish a lot more. But I'm not going to talk about, I'll talk about loss in those, but not right now, as I said. What we can look at is the accuracy, though. So you can see what an epoch is. It's kind of one training phase, if that makes sense. So it runs through it, and then it takes that data and runs it again. All right. So you can see here we have an accuracy of 92%. So what it's actually doing is it has an expected output, and it's testing it. So that's how it finds the accuracy. Perfect. So we actually have it here, the 2. And then, so the first epoch is pretty good, but you can see we actually gradually improve. We have a 96 on the next, and we have a 97 on the third. So we have great accuracy here. And then I'm also using matplotlib that I forgot to tell you guys in the start of the video, but that's why you can see it kind of graphs it for us too, so we can see it. But you can see it predicted it too, so we could test this out for a few more if you'd like. So I have another image. I think, yeah, I have one of a 7. So let's upload this. Alright, I guess it didn't upload yet. Alright, so it's right here. If you want to see it, you can. So you can see it's a 7, but let's see if our network can predict that. So you just have to change this to digit 1 because this is what the file name is. And now let's run this and see what happens. So what we kind of want to look at is this accuracy and see how it kind of improves. So you can see I have a 92 here, and then we go to a 96, and then finally we're already at 97. I think we're gonna hit. Or yeah, so we have 97. So kind of like the same accuracy. Obviously, it's a different digit, but you can see it does predict a 7. So that's really cool. Alright guys, so that's it for this video. Hope you guys enjoyed. If you guys did, please hit that thumbs up button down below. If you guys still like to see more videos like this, you can hit that subscribe button down below. But once again, that's it for this video. Hope you guys enjoyed. And until next time.